Welcome to session 215. 215, we're going to be doing the same thing, just a little more in depth. Uh, we start off with a multiplication of rational expression, strictly multiplication, but this time the difference is that there are three terms, not just two, but three. So here we go. The first thing that you should remember, look, I have all pluses and minuses in every numerator and denominator. I have a plus or a minus, one or the other. So therefore, I must separate and factor, just factor. So I take this numerator, x squared plus 7x plus 10, and I factor. Nothing in common, so therefore it's going to be two sets of parentheses. X, X. This is a plus. That means they're both going to be plus. 10 is going to be 2 and 5. Double check. That's 5x plus 2x is 7x. I'm okay there. The denominator, x squared minus 4x plus 3. Nothing in common, so I have to have parentheses again. X squared is x and x. A plus 3 means the signs are the same. They're both going to be minus, minus, minus. Or 3, that's easy, 1 and 3. Minus 3x minus 1x gives me minus 4x. Do you see I didn't just come up here and cancel x squared? I can't do that. I have to use that to factor. The only way I can cancel x squares is if there are no pluses or minuses anywhere. But there are, so I can't. So I have factored this numerator and this denominator. I'm ready to do the next fraction. X squared plus x minus 12. No common factors, so I'm going to do parentheses. X squared is going to be x, x. A minus 12 means the signs are going to be different. So let's try 3 and 4. How about a plus and a minus? That gives me a minus 4x, and a plus 3x gives me a minus 1x. The 1x is the right number, but it's a plus. So I just simply change this to a plus, this to a minus. Remember that? So plus 4x minus 3x gives me a plus 1x. Now we're ready for the denominator. X plus 5. All I have to do is keep parentheses around it. X plus 5. There is a plus, so I do need to put it in parentheses. There's no common factor. It doesn't have an x squared, so it's factored. It's just x plus 5. Okay, next fraction. X squared plus 6x minus 7. Okay, no common factor, so x, x, 1, 7. I'm going to put minus and plus. That's plus 7x minus 1x gives me plus 6x. So I'm okay there. Over. No common factors. X squared would be x, x. The signs got to be a plus, so that means they're going to be the same. They're both plus. How about 2 and 4? 4x, 2x gives me 6x. You notice I couldn't just cancel the x squares and the 6x and leave 7 over 8. I can't do that. There are pluses and minuses there. So I have to factor using these parentheses. I have to factor. Okay? The denominator here, x plus 2, x plus 4. I have a glare on it. I hope you don't. But. Okay, remember the rule now that I have them all factored. I can cancel any numerator with any denominator. So, let's try a different color and see if that helps me. X plus 2. Well, there's an x plus 2 down there. Okay. X plus 5. Well, there's one right there. X minus 3. Well, here's one down here. See, it doesn't matter which fraction they're in. Just any numerator with any denominator. X plus 4. Well, there's an x plus 4. X minus 1, x minus 1. X plus 7. I canceled everything in the denominator. So therefore, I only have x plus 7 is my answer. There's no denominator because all of this, when you cancel something, it's 1. 1 times 1 times 1 times 1 times 1 is 1. In a fraction, if the denominator is 1, you do not write it. You only have to write it if the numerator is 1. The denominator, you do not write it. Okay? So this is my answer. If you put it in parentheses, fine. If you don't, that's fine too. But because with a plus sign, it automatically should put parentheses around it. Okay? So that wasn't very much different from what you were doing before. You just went from 2 fractions to 3 fractions. So no big deal. Okay? This one. I have 3 fractions, but I have a division there. With division, the first thing you should automatically do is rewrite your problem flipping the division fraction. Remember, that's the first thing you should do. So I'm going to rewrite this. X squared minus 1 over x squared minus x times 3x over x plus 1 times x over 3x squared plus 9x. There's a plus in this expression, a plus in this expression, minus in this expression, minus in this expression. I have to factor. I've changed it all to multiplication, so it's just like the previous problem. Now I factor. X squared minus 1, nothing in common, but it is the difference of 2 squares. So therefore, I have x minus 1, x plus 1. Remember the difference of 2 squares. That's a perfect square. That's a perfect square. So I have the same thing except one's plus and one's minus. Denominator. Common factor. Take out a common x, and that leaves me x minus 1. Okay? Times 3x. There's no plus or minus there, so I just leave it. Over x plus 1. Put parentheses. Times x over Common factor of 3x. That leaves me x plus 3. Now we're ready to cancel. X minus 1 can cancel x minus 1. But wait, they're right above each other. They're in the same fraction. It's just like reducing a fraction. So any numerator with any denominator works. Okay? X plus 1, there's an x plus 1. 3x, well, there's a 3x. That's easy. X and x. Don't forget this one over here. Okay, I've canceled everything in the numerator. So that means the numerator has to be 1. The denominator will be x plus 3. Okay? Next example. Oh, wait. That looks funny. 3x over 3x squared minus 27 over 2x plus 6. Different, isn't it? This means, you see that this line is a little bit bolder. So that means that it is 3x divided by 3x squared minus 27 over 2x plus 6. So we're going to work with it in this format. Not this one, but this one. We just uncomplicated it. Okay? This is a complex fraction. Okay, one term divided by this fraction. Okay? That would be sort of like saying 2 divided by 1/3. This is similar to what you would be seeing. 3x divided by, and then that would be like the 1, and that would be like the 3. That's not it, but it's similar. Okay. 3x over 1. Flip over division. 2x plus 6 over 3x squared minus 27. And I do require that you show this work. 3x over 1 is fine, but these over here have pluses and minuses. I must factor 2x plus 6. Common 2, and that leaves me x plus 3. Common 3. That leaves me x squared minus 9. Whoops. Little catch there. I still have an x squared. If I have an x squared, I still have to try to factor again. So this is going to be 3x over 1 times 2 over x plus 3 over 3 times x plus 3 times x minus 3. Remember, that's the difference of two squares, a perfect square, x, 3. One's plus, one's minus. Now to cancel. I have a 3 here and a 3 here. And you're going to say, but I can't cancel. It's got to be all or nothing. There are no pluses or minuses here. There's no plus or minus with that. The rest is in parentheses. Okay? You see the difference? I hope you do. Okay? 2 doesn't cancel anything. It would cancel by itself. X plus 3, X plus 3. So that leaves me with X times 2 is 2X over X minus 3. And that's my answer. See, this is very much like what we were doing the last lesson. Oh boy, doesn't that look like a complicated fraction? Remember what we did the last time. We have a fraction over a fraction. So it's going to be x squared minus 36 over x squared plus 15x plus 54 divided by 2x squared minus 5x minus 42 over 10x squared plus 33x minus 7. See, I first had to write that into a division problem. There's my division line right there. Now, if I have a division, I must change it to multiplication before I even do anything else, okay? X squared minus 36 over x squared plus 15x plus 54 times 10x squared plus 33x minus 7 over 2x squared minus 5x minus 42. This is all one expression, this is all one expression, this is all one expression, and this is all one expression. Now I factor. X squared minus 36. X squared breaks down into x, and 36 breaks down into 6. So one's plus, one's minus. It doesn't matter which is first. That's a difference of 2 squares. See, difference, perfect square, perfect square. Remember, difference of 2 squares. X squared plus 15x plus 54. Well, nothing in common, so let's do this. X and X. The signs are going to be the same. They're both going to be plus. 54 is 9 and 6. So that's plus 9x plus 6x gives me plus 15x. I'm okay there. No common factor. So I break it into 2 parentheses. 5x, 2x. 7 is kind of easy. 1 and 7. That says the signs are going to be different. Let's just put a plus and a minus and check them out. Minus 35 plus 2 gives me a minus 33. I want a plus 33. So just change the signs. This becomes minus. This becomes plus. Plus 35 minus 2 is plus 33. Over. No common factor. So 2x and x. 42 is 6 and 7. Well, all right, let's try 6 and 7. One's plus, one's minus. That's a minus 14 and a plus 6. Does not give me 5. Doesn't give me 5 either plus or minus. So my 6 and 7 might be in the wrong place. Let's try it here. 7, 6. Minus 12 plus 7. Hey, it gives me a minus 5x. So I'm good. Now we cancel. This is the fun part, canceling. Just don't get so carried away. Don't mark out a whole section. Like if it was 2x plus 7, when you're canceling, don't mark out the whole thing. Just do the one line so that you can see what's left, okay? X plus 6, x plus 6. X minus 6, x minus 6. 5x minus 1, no. 2x plus 7, 2x plus 7. So that leaves me 5x minus 1 over x plus 9. Okay, so very little difference in what you were doing the last time. They just add that one extra little step. Some of the problems may not even have that extra step. So it's just more practice in multiplying and dividing rational expressions. Okay? Remember, the assignment's in the description part of the lesson on the computer, and you must show all your work. If you don't show all this work, I'm not going to give you credit. You have to show your work. You could not do this in your head. So if you're going to have to do it on your paper. Show it to me. Okay? Any questions, any problems, be sure and call. Okay? Have a nice time with this.